Hi, this is segment 3 of the groundwater. Um, and right now we are at the karst system. And karst is a special type of landscape and it forms by the dissolution of the limestone and dolomite and other soluble rocks, but mostly the limestone and dolomite because of the carbonic acid in the groundwater, I mean in the rainwater. You know, the CO2, the water and the CO2 in the air produces CO2, produces, and it's balanced as it is H2 CO3, which is the carbonic acid. I think it's written down somewhere, but I'm not sure. But anyhow, this is the reaction. So therefore, the water, the rainwater, is always acidic. If you remember, it's about 5.5 pH. So therefore, when the rain falls onto the limestone and dolomite, it actually will dissolve it. And the karst region will contain aquifers that are capable of providing large supplies of water. Most of the time, they will form in humid climates. Uh, and these rocks are extremely conductive. So they can really be bad source of fast spreading solution, like if you think of 81 from New York, Albany, New York, goes all the way down to North Carolina. No, I mean really just Virginia. I think it goes into Tennessee. Yeah, that's it. Yeah, it goes to Tennessee. And if somebody puts pollution up north into the limestone along 81, it's going to go down really, really, really quick. So because they are extremely conductive, they're full with caves and other solution cavities, the pollution can spread really, really bad. So we really have to learn about the karst so we can try to avoid um, these kind of problems. This slide just shows you a map of the US. Uh, all the black areas are karst areas, so you can see it's more than 20% of the land surface is karst, and 40% of all the drinking water actually is coming out from karst aquifers. The karst are extremely uh, porous and permeable. It's amazing, but we have to be really careful because, as I said, because of the pollution, it can poison a lot of people really, really quick. The karst landscapes are most of the time an amazingly beautiful areas. Um, some of the most amazing places are the Grand Caverns and the Mammoth Caverns in Kentucky, the the major crystal springs in Florida, crystal clear springs in Florida, and then in New Mexico there's a lot of caverns. Probably the most well known is the Carlsbad Caverns, but here in Virginia we have a lot of caverns, and it's like the some of them, the Grand Caverns, the Luray Caverns, the Natural Bridge Caverns, Dixie Caverns, and there are hundreds of caves which are actually wild caves. That means you have to have special permit to go into them, and they are not very easy to go through. It's nothing like the touristic caves. So what happens, uh, as I just told you, that most likely it's going to be on one of the slides. It's right here. That's the reaction for the CO2 of the water making carbonic acid. And I told you that this carbonic acid charged water moves laterally along the horizontal. See, the limestone will always have horizontal layers, but then they also have vertical fractures or joints. And so the water seeps into the rocks along these joints and it has acid, so it actually dissolves it. And especially around the water table, because the water stagnates here, so you start seeing actually caverns forming. And as soon as these are big enough from the surface, some of the surface waters will actually come into the cave We call it disappearing stream. And that will actually, as the stream go into the cave and enlarge it even further, more than just the acid rich water. And of course, not only that, but also it has pieces of rocks and it braids the holes bigger and bigger. So when we go to Dixie Cavern, we'll see all this. One of the most interesting surface feature which shows you that there is limestone area there is the sinkholes. And when the enlarged vertical fractures are going to allow the soil and the rock debris to collapse, that's how the sinkholes will form. As you can see, this area is completely pitted. This whole area is completely pitted with sinkholes. So you can almost see which way the limestone is going. And then if the water table where the first cave system forms, if the water table drops, then you're going to have a whole system which are empty, and you will see a lot of cave collapses. And also you start seeing the formations in the cave. So this slide just shows you the principal cave features. The cave itself, it's a previous water passage which is now air-filled, and a human can stand up in it, and that's what we call cave. Very characteristic is the disappearing streams. The disappearing streams is when throughout the enlarged joints the stream actually goes into the cave and flows in the cave, so it's disappearing from the surface. That's why we call it disappearing stream. Then you've got natural bridges and tunnels, and natural bridges are basically forming by cave collapses, because when the hole becomes empty because the water level dropped, then the hole cannot hold up. Since it's not filled up with water, it will actually just collapse. Sometimes the collapse doesn't open up to the surface, so you're just going to have bigger and bigger hole, and then on the middle of it, you're going to have these big rock piles, which is coming from the collapse. But sometimes actually it completely collapses, and all you have left is a natural bridge. And that's what we got in Virginia at Natural Bridge. It's kind of dangerous because if you think about it, 11 is going through that natural bridge. So as people walking underneath, the cars are shaking the whole area, and rock can fall onto tourists, like happened a couple of years ago. So be always careful when you cross under the bridge. Go as fast as you possibly can, so the rocks don't have much time to fall on you. The sinkholes we already mentioned, and then you have springs. When the disappearing stream comes back to the surface, it will appear as a spring. So these are the most important features of the Karst system. And here is a couple of amazing. When a karst is just starting to form, probably the first signs is a couple of sinkholes on the surface, and you have a cave close to the surface. But then the groundwater level drops, so you have an empty hole system, and then the water level drops again, and you have another empty hole system, and the first ones are collapsing, and you might have multiple collapses. And when the karst system becomes very, very old and mature, you're going to end up having these amazing towers, because now the natural bridge also collapsed. You know, there used to probably be a natural bridge right here. Then it collapsed. So now you just have the so-called amazing karst towers. You have them in Thailand, in China, a lot of amazing places. Anytime you see something like that, and the rock is white, you know it's a collapsed cave system. And this here shows you a very typical sinkhole. There is a lot of them in Florida, as you know, but it can happen anywhere along 81, and it does happen a whole lot of the times. And that's a typical small little sinkhole in one of the fields. Again, there is a map of the USA showing you all the karst areas. This 81, as I mentioned it to you, right here. So anywhere along 81, anytime we can have sinkholes. You know, as you can see, everything in Florida is karst. So do you want to go to Florida? You have to be really careful because your house can anytime go down on a sinkhole. So I would have it checked out, like by, there are some close to surface geophysical methods which can show if there is a cave underneath where you build. So I would be very careful before I build a real house there. These are some of the formations, and I'm not going to really talk about this because we're all going to go to Dixie Cavern and I actually will show it to you. But one thing, the so-called helictite. Helictite is when the stalactite doesn't grow down but grows sideways. That's the helictite. The problems with groundwater, there is a couple of them, and on the test you really will have to know. I will ask problems with groundwater, so you really have to know. You have to know all of them: the subsidence, the saltwater incursion, lowering water table, and the contamination, all of them. So let's start with the subsidence. When you got subsidence, you need to have unconsolidated sediments, such as like coastlines. All we have there are sand, quartz sand. They are not cemented, they're just sand. And while they are filled up with water, everything is good. But when they drill down and start pumping the water out, and if the pumping is about the same everywhere, the whole ground just starts to go down. As the water comes out, the sand is actually compacting. So the whole area is just going down. Um, One of the most amazing, the largest amount of subsidence is San Joaquin Valley, California. San Joaquin Valley, California. And this picture here shows just that. In 1925, this was the surface. And in I cannot read it. It tells you right there on that thing. 1997, it tells you right here. 1977. So 1925, 1977. So in 25, 70, that's 52 years. And this is how much the subsidence was. So it's pretty amazing. Actually, subsidence can, if the subsidence is not equal, it can cause a lot of leaning towers. Like the leaning tower of Pisa is caused by subsidence. You know, like if one place it's larger than the other, one well pumps more water than the other, then of course it can cause these leaning towers. This map shows you subsidence around the world. And you can see, and this shows it in meters. So 8.8 meter times about 3 is like 25 feet or more. And then you see there is some in Denver, but mostly in Houston, that's like 9 feet. Mexico City is almost like San Joaquin Valley. There is Venice, 0.2 meter, which less than a feet, and so on. The next one is the saltwater incursion. And when you are in a coastal area, it's important to know that the saltwater is heavier than the freshwater. So if you have an island or like in Florida, you know, the beach, the freshwater, because of the rain, is going to sit on top of the saltwater because it's lighter. The two will not mix. So basically, when you put a well in and you pump it, remember it will have the cone of depression. So if you over pump it, sometimes it might happen that actually the cone of depression goes down to the salt water, so the well starts sucking salt water. As soon as a well goes into salt water, it will never go back to fresh water, so you might as well drill a new well. This is what we call saltwater incursion. It's very important that in coastal places like Florida, that they will always drill a recharge well, and as soon as they used up the water, they clean it and they put it back in the ground, so the groundwater level is always kept up, so you cannot mess up the wells. The next one is the lowering water table, and you know this is when you pump a certain water and the cone of depression tries the shorter wells in the neighborhood. And the last one, which is really, really important, is the contamination. And as you know, human development has added a lot of potential pollution source that may contaminate the water supply. And you guys know, you have heard a lot of horror story. The the pollution may be associated with like a specific source, and we call it like a point source. But sometimes it could not be traceable to a single point of origin, and in this case, we call it non-point source. And usually it happens like when they fertilize croplands. The fertilizer, a lot of the cases, are actually bad for us. And this picture just shows some contaminants from landfills and places. This is how the point source contamination is moving. You know, it depends on, of course, the gradient of that area, the porosity and the permeability of the rocks. And remember, the pollution always goes down with the groundwater. So if your house happened to be here, you go good. If your house is here and your well is pulling up water from the pollution plumb, you're in trouble. Some other pollution problems. If you have leaking gasoline, the gasoline will float on water, and sometimes it dissolves in groundwater and transported by groundwater, and it contaminates. The gasoline is probably the most dangerous. Just a couple of molecules can cause cancer. That's another one here, showing different, like septic tanks can contaminate water. Landfill, of course, landfill, when the landfill didn't have liner underneath, and the leachate gets into the ground, then it can really cause major pollution. Fertilizer, pesticide, the road salt, surface water runoff if it gets bacteria in it. So there's a lot of bad sources for pollution. So here are some other potential pollution sources in the US. We have about 3,000 landfills, along with thousands of illegal dumps that may leak chemical soup of waste liquid. You know what's happening at the Dance River in West Virginia. There is always a lot of problems about this. We have a lot of domestic septic systems, which actually, let's say here is your house, here is your septic system, and your septic system leaking, and here is your neighbor's house, the neighbor's well, and your septic system is leaking into the neighbor's well. So they drink what you have in the septic system, which is very bad. So you always have to look at your backyard, and you must know that the water table is a replica, more or less, to the surface. So if your neighbor is above you, you really need to know where is his septic tank, because you don't want to drink that. We have a lot of active and inactive underground storage tanks, which could store like gasoline or industrial chemicals. Sometimes they're actually on the surface, and it's just as bad when they start leaking. We have abundant oil and gas wells. You know, we have the fracking, which can put some really bad stuff into our well water. We have abundant coal and oil metal mines, which really can produce a lot of acidic runoff, which can go into the drinking well. Sometimes you have animal wastes, and especially the chicken is really can cause a lot of problems for the drinking water. And of course, all the fertilizer, pesticide, the icing salt along the road. So this is all can cause a lot of pollution. And these are just a couple of chemicals and what they cause. If you have any benzene in the water, it causes cancer. And that is all the leaking fuel tanks and industrial solvent. Toluene causes kidney disease, which is coming from chemical manufacturers. It's an industrial solvent. And then this here is dry cleaning, and we had that in Roanoke, and it causes cancer big time. Then we have the inorganic chemicals such as arsenic, which can cause a lot of cancer, skin lesions. The nitrate can cause blue baby syndrome. Nitrate is the fertilizer, one of the fertilizer. And then, of course, the lead causes nervous system problems. So none of them are really good. And these are the microbes, which bacteriums, and they can cause a lot of stomach problems, and it can come from human or animal wastes, basically. And I guess we just finished the groundwater chapter, and I hope you enjoyed it. I'll see you in the next chapter. Bye.